Okay, let's look at practice exam number 2, problem number 8. All right, so we want to find the point on the graph of f of x equals square root of x minus 3, and that is closest to the given point 7, 0. All right, so let's say any point on this curve can be written as so x comma f of x, which is square root of x minus 3, right? So since we can probably name these guys as x1 comma y1, right? And we can name these guys as x2 comma y2, right? Then we can use the distance formula, which is something like d is equal to, right? It's going to be a square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared, right? So following that, we'll get square root of, right? So x2 is x minus x1 is 7, right? Squared. So x2 minus x1, right? Plus, right? y2, which is square root of x minus 3 minus y1, which is 0 squared, right? So we can simplify this a little bit more. So I'm going to just go ahead and multiply out. So that's going to be x minus 7 squared would be x squared minus 2 times 7 is 14x, and the 7 times 7, so it's going to be 49, right? But if you square root of x minus 3, so you're going to have x minus 3, right? So clean it up. So you have a distance formula is a function of x, which gives you, so this is going to give you, right? So square root of, right? So there's a x squared here. So you have x squared. And then you have negative 14x and x. So it's going to be negative 13x, right? Then you have 49 minus 3, so it's 46. Right? So I'm going to call this inside function here g of x, right? Right? Instead of minimizing this distance with the square root, it's a little difficult, so I'm going to go ahead and try to minimize just the inside the square root, right? So try to minimize the g of x, right? Which is x squared minus 13x plus 46, right? Right, then since the domain of this function is 3 and up, so domain of f, maybe I should mention that here, domain of f is starting from 3, right? Because if you put anything smaller than 3, that's going to be negative, so we can't have a negative number inside the square root, and a positive infinity. So we are trying to minimize this function on the interval from 3 to positive infinity. All right, so let's take the derivative. So derivative of g of x is g prime of x is equal to simply 2x minus 13. All right, set that equal to 0 to find the critical number. All right, first step would be add 13 to give you 2x is equal to positive 13. Then we can just divide it through by 2 to get x equals 13 over 2. All right, so we have a critical number, so this guy is a critical number. All right, then we want to make sure that this is going to give you the minimum, so we're going to look at the number line just to make sure. All right, so x, and it starts from 3. All right, so 13 over 2 is like 6.5. So let's say somewhere around here. So 13 over 2. All right, then if you look at the sign of g prime, so we'll try anything between 3 and 13 over 2. So like 4 or something like that. All right, so if you plug in 4, 4 times 2 is 8 minus 13 is negative. All right. And after 13 over 2, like x equals 7, you can see that the 2 times 7 is 14. 14 minus 13 is positive. So the g prime is positive there, right? Which indicates that if you look at the original function g, right, it's decreasing before the critical number 13 over 2 and increasing after the critical number. Right, so this indicates that we're going to have a minimum at the critical number, which is 13 over 2, so you have a minimum. All right, so we know that at the critical number, the distance will be minimum, so we just have to find the corresponding y value. All right, so we just have to plug in 13 over 2 into the function. All right. So this is going to be x is 13 over 2. And we are subtracting 3. 3 is same thing as 6 over 2. Right? So that's square root of 7 halves. All right, so the closest point that we are looking for is going to be x is 13 over 2. And the y value is square root of 7 over 8. Right? So that is the closest point on the graph of f of x to this given point 7, 0. All right? That's it. I hope that this was clear.